Good morning, students. Welcome to online classes. Today's session regarding to EE 304 C18 electrical and electronics measuring instruments. In that, three-phase energy meter. Before that one, my sincere thanks and courtesy to all authors for sharing their valuable materials in internet for student purpose. So what we have seen in previous classes. In previous period we have learned about single phase energy meter. Have you remembered this one? What is this one? This is a single phase energy meter. What is the energy meter? Already you have seen, which will measure the energy from the circuit. What is the energy meter? An integrating instrument which measures the quantity of electric energy supplied to a circuit in a given time. Okay, so what is the meaning? Already you have seen. At the same time, what is the basic principle of this induction meter? So an induction instrument, a deflection torque TD is produced due to the interaction between the flux of an AC magnet and eddy currents induced in a magnet, the metal disc, that is the aluminum disc. And as you know that it has the four main systems to work this one. What are the main systems? So in this one, if you are seeing the mainly one is the driving system. Okay, driving system. Another is the moving system and braking system, and lastly the recording system or registering system. Okay, what is the driving system? What is the moving system? What is the braking system? What is the resisting system? Already we have seen. Okay, in previous classes we have seen. What is the driving system? It consists of the two magnets and M1 and M2. M1 is the electromagnet that we can say is the current coil. It has the few number of turns. A thickness of the wire is more. Whereas M2 is the pressure coil, it has a large number of turns, a thin wire. And in addition to the current coil and pressure coil, so we are also used the copper shading band to adjust the phase displacement between the parallel coil, pressure coil, voltage and flux produced in the pressure coil phi2. Okay, already we have seen. So here the series magnet M1 is connected in series with the load, and whereas the shunt magnet M2 is connected with parallel across the supply. Then shunt magnet measures the voltage and series magnet measures the current. As we know that the power, whatever the power we used in our houses is recorded by the energy meter. Power into time equal to the energy. Okay, so here the flux produced in the current coil is directly proportional to the current drawn by our loads. If the more current comes, so more flux will develop, and this flux is in phase with the current. Whereas in shunt magnet, that flux produced phi2 is directly proportional to the voltage across the supply. At the same time, the flux produced in the voltage coil phi2 is lagged by the 90 degrees with voltage. This phase angle between this flux phi2 and supply voltage V1 is adjusted such a way that by using the help of the shading ring. Okay, and this shading ring is the copper shading bands or power factor compensator, sometimes we can say, that is provided on the central limb, and this position is adjustable, move up and down, already we have seen. Okay, so these are the basic systems inside. And coming to the moving system, driving system, we have seen these are the driving systems. And coming to the moving system, what is the moving part in a single phase energy meter? We have seen only aluminum disc. It rotates on a steel pivot. The pivot is screwed to the foot of the shaft, and a pinion engages shaft with a counting or registering mechanism that can measure the how many times of our disc will rotate. Okay, so at the same time, once it rotating, due to the interaction of the fluxes phi 1 and phi 2, that will produce the corresponding the eddy currents I 1 and I 2. The interaction of this phi 1 phi 2 and I 1 and I 2, there is a torque is developed. The torque will try to rotate the disc in a air gap. So if the disc is rotating in one direction, that direction can be changed by changing the current direction of current coil. Okay, once the rotor is rotating, that is the disc is rotating here, so we required some braking system also. So that is the braking system is required. What is the braking? It consists of two permanent magnets called the braking magnets. They are placed diametrically at the edges of the aluminum disc, and aluminum disc moves in the field of magnets M1 and M2. So aluminum disc provides the braking torque, and position of the permanent magnets is adjustable. So in the inside and outside, based on the inside and outside, we can change the rotation of our disc. Okay, so these all things we have seen in previous classes. At the same time, also we have seen resisted. So how many times the disc is rotating in the air gap between the M1 and M2. So based on this rotation, based on the number of revolutions, it can record at the top. So the registering and counting mechanism mainly function is record the continuous number of rotations. The number is proportional to the revolutions made by the moving system, and it consists of a worm and worm wheel, and the rotation of the spindle is recorded on the cyclometer. Last class we have seen, and the ratio of the wheels are designed to give the energy for a set of revolutions of the aluminum disc. Okay, so dear students, these all are covered in previous class in details. Okay, similarly, same setup is arranged in three-phase energy meter also. What is the basic principle? So as we know that, what is the basic principle? So we know that, so due to the, once again, so same principle here, three-phase also. So here I am going to use it. So it consists of upper magnet, and it consists of lower magnet. Okay, so it has one aluminum disc also. This is equal to, we can say this is the M2, this is equal to M1, this is a aluminum disc is provided here. Okay, now what is happened here? I am going to connect the wires. It's a currenting comes, for example, this is a phase wire and connected here. So this one coil, few number of turns, thick wire connected to our load. Here I connected the load and is going to connect to the neutral. Okay, this is neutral. That is, the load is connected in series with the M1 coil. At the same time, it is also connected with the center limb. here. So that means this is a PC coil, this is a CC coil, current coil and PC coil. And at the same time, so we also have another shading ring, shading coil provided here. One shading coil is also provided. We can adjust and up and down to adjust the phase angle. Okay, these are the basic construction. What is happened? So when the energy meter is connected in the circuit, the current coil carries the load current, whereas the pressure coil carries the current proportional to the supply voltage. The eddy currents are induced due to the flux phi 1 and due to the flux phi 2 of M1 M2 in the aluminum disc. The eddy currents produces its own E1 and E2 in the disc. Due to this one, it produces the currents of I1 and I2. Due to the phi 1, phi 2 and I1 and I2, these are the main components to develop TD. What is the TD? Deflecting torque. Okay, the eddy currents are induced in the disc due to the fluxes established with the series and shunt magnets, causing a driving force which results in disc to rotate. Once disc is rotating, it connected to the shaft, and shaft is connected to the worm and worm wheel, and it can record the how many number of turns rotated our aluminum disc. This is a basic principle we have seen in previous class. Okay, so dear students, please recall. So what we have seen here, we connected the two-phase system. That means here you can see it. Here, what is the energy meter? We connected energy meter here. So it is consist of 4 terminals. Okay, so it consists of CC coil, PC coil inside unit. Now here my nearby pole, I have the only single phase supply. Okay, single phase supply. Now I can take the service wire. Okay, now we connected the phase. At the same time, so we connected the another color, you can take it. So if neutral is can take, another is connected to the neutral. Okay, so this is a phase, this is a neutral. And what are the phase is connected to here? So it is connected to the CC coil. Okay, CC coil, and coming to the outside here. And what are this connected is connected to the center coil and connected to the neutral. Okay, so here connected to the neutral once again. So neutral is the phase, it's the output, and the neutral is this one, it is connected to the neutral. Okay, so here connected this one. Now this is the neutral, this is the phase. Okay, so that means what are the phase and neutral? 2 wires, single phase. This is a single phase, it has the phase and neutral. That's why it has a one aluminum disc. Okay, so what you have seen? So one is the M1 and M2, one is the aluminum disc inside. Okay, so if you are connected, suppose here what will happen? Here connected the small house. I have the small house, I have the load less than 1 kilowatt. Okay, 1 kilowatt. I have the 2 fans, 5 tube lights, 1 TV, fridge. This is some load I have it. So that's why I taken the single phase. Suppose due to my promotion, I have more salary, then I am going to use one big building, multi-store building, for example, have the multi-store building. Then what is happen? So now automatically, so I require the more power to my electrical loads. Okay, I am going to use the different AC systems, air conditions and different applications. then I cannot use this single phase energy meter. If I want to use single phase, I have to use one single phase meter to the ground floor, another single phase energy meter for the first floor, and another single phase energy meter to the my penthouse, and another one single phase meter for the total lighting for the common purpose. Okay, here the 4 or 3 energy meters is required. That purpose I have to connect the one common bus bars. These are the 4 energy meters are required. So I have to take the 4 service wires, and each is connected to the individual floor. Okay, one is connected to the common floor. Suppose I have I intention to give the rent, then I require the 4 and single phase energy meters. Instead of using these 4 single phase energy meters, I can use only one energy meter. So then how to use? I can, instead of these 4 energy meters equal to, I can use the single energy meter to meet my load. That is known as the 3-phase energy meters. Okay, so RYB neutral, RYB. I can use a single wire. This is equal. I can use the one copper cable which has the RYB and neutral. So 3-phase 4-wire system. I can take it from this one. I can connect this all to the my load. So one phase is connected to the by using the MCCB and MCCB, and another is the MCCB and another is the MCB. You can see the MCCB or MCB can be used less than the 100 amperes, and MCCB can be used with the more 100 amperes. Okay, so you can use normally you can take the MCB. Okay, you can take the MCB. So this is the first floor, the ground floor, and the penthouse is a common. I can use from this single. Okay, so this is easily I can pay the only one single watt meter. This is energy meter rating. Otherwise, what will happen? I will take the 3 bills. So there is a constant losses or everything. So instead of using these 4 energy meters, I can use only single energy meter. That's why we can see that this is a 3-phase energy meter, and purpose is same. So where the load is more, it is preferable, it is advisable to take the 3-phase energy meter instead of taking the 3 to 4 energy meters. Okay, so we have seen what is the single phase energy meter, what are the different parts of the energy meters, and how it will works energy meter. Similarly, our single phase, this 3-phase energy meter also same basic principle, but construction point of view it has some differences. What are the differences? We are going to learn in this class. The principle is same. So here what is happened? So we have seen only M1 and M2 one disc. So in 3-phase energy meters, so we are going to get it is a 2 aluminum discs, or sometimes we can use 3 aluminum discs, 1, 2, 3 separate phases, and common shaft is connected. Here also common shaft is connected here. Okay, this is a 3-phase energy meter. This is a 3-phase 3-wire system RYB. This is a 3-phase and 4-wire system, that is the RYB neutral. So in this case, aluminum disc, aluminum disc, aluminum disc. Here also aluminum disc, aluminum disc. So what will happen? So here same it consists of where is presents the aluminum disc, it requires the 2 brothers. One is the M1, another is the M2. So here what is happened? Here you can see. So here 3-phase, if you are observing. So what is happened? Here is the aluminum disc. Okay. So what is happened? Here you have to go to provide the one this coil, and at the same time another disc require the another arrangement. Okay, so this is the basic idea of energy meter. Now what is happened here? Due to the this aluminum disc, this is aluminum disc, and this is the aluminum disc. So I am connected the one common shaft. Okay, so it records connected to the registering unit. Then what will happen? So if it rotates, it is also rotating this one. And whatever the supply is given R phase, so you are going to connect the 3-phase supply system. There is a R phase, this is a Y phase, and this is a B phase, this is a neutral. So you have to take the one cable, R phase and Y phase and B phase and neutral. So based on this one, you are going to give the insight. Okay, so how you are going to use? So I can just take the energy meter. So for example, this is the energy meter, and so you have the terminal box. Okay, you can see the energy meter, this one, and this is the terminal box. So whatever the, you take the R phase, this is a Y phase, this is a B phase, and you are going to connect the neutral also. This is the input terminals. Now coming to the output terminals, you take the same R phase, Y phase, B phase, and common neutral. So this is known as the output terminal of energy meter. Okay, so what is inside, how we are connected is similar to the single phase. So each unit, so here you can say this one element, we can say this is the one element, this is the another element. That means you can say the 3-phase 2 elements system. So this is the one element. What is the element consist of? Same M1 and M2 and disk. Similarly here also M1 and M2 disk. Okay, so these are the common things. Only difference is this one. So in previous case we have seen the only single, this is the single phase energy meter. So that thing, but this is also single phase energy meter. Now combining this one, we are going to get the 3-phase energy meter. Similar to the measurement of power in a 3-phase system by using the 2 wattmeter methods. Or so we can also the 3-phase power can be measured by using the 3 single wattmeters. That is another case is the, so we are going to use it. So here 3 discs. Okay, so here 3 discs are the, this is a one disc, and this is another disc, and there is another disc, and connected to the same shaft. It connected to the resistance system, and here we require the same, this is one magnet, this is another magnet, and this is another magnet, this is another magnet, and here also another magnet. This is the, this is all, dear students, these are all electromagnets. Okay, so here what is happen? This is the M2, this is the M1 for R phase, this is the M2 and M1 for Y phase, this is R phase, this is a Y phase, this is a B phase. Okay, so now as we know that all the M2 always M2 is a PC coil, pressure coil, it is connected in parallel. So in parallel we are connected, the one is the R phase, another is the neutral. You are going to connect here. Y phase neutral, B phase neutral. Okay, so these are the inputs. Similarly, you can take the outputs. Whereas in this case, what will happen? You are going to connect the so R phase, Y phase, B phase. So R phase is a, that means it has a CC coil and M2 is connected across this R phase, Y phase, for example, and here and the M2 of R phase is connected to the R and Y, and the M2 of B phase is connected to the between the B and Y, and whereas here M1 is connected in series with the R phase, and M1 connected in case of the B phase in B phase. Okay, so don't bother about this one. We will see one by one in details in the help of the our PPT. Okay, this is a basic idea, dear students. So based on this concept, you are going to enjoy so how this 3-phase energy meter works, operates. Okay, let us do now. So what are the objectives? On completion of this topic, you would be able to know one is the construction and working of three-phase energy meter. Okay, so you can see in domestic, you can observe this is a three-phase energy meter. So these are the, you can see this is a MCCB. These are the MCBs. So what are the MCCB? MCBs already we have seen, protective equipments. This is a three-phase energy meter. You can observe the number of wires is increased here. In case single phase, so only 4 wires, phase or neutral input side and phase, neutral in the output side. But whereas in this case there is a possible to 8 wires, or sometimes we can say the 6 wires. Okay. Now you can see here, so where we require three-phase energy meters. So why not use the single phase energy meter? So here you can see the once this size of the load increased, the number of floors increased, automatically the electrical load also required more number of air conditions, number of fridges, number of lighting loads increases. Obviously you have to increase the capacity of the input. So that's why I am going to use my three-phase energy meter. From this energy meter I distributed to the this one. You can see this is a distributed different floors. Okay, that is the main requirement of three-phase energy meter. So in single phase you have seen inside. Okay, so one disc consists, it has the M1, M2. Now you want to see how its inside 2 elements consist. Let us, have you seen the three-phase energy meter? Just now you have seen. Now olden days we have the another type of the three-phase energy meters, you can see here. So this is the three-phase energy meter. If it is opened, the cover is open, then inside there is a parts. Now you can see the this is a one aluminum disc, this is the another aluminum disc, and it is connected the common shaft, you can observe here, and common registering unit counts. Okay, so you can see, so here wherever the disc is present, there is a M2, M1 of one element, here also M1, M2, this is a M1 of another element, you can see in the figure. Okay, clearly you can see there, and at the same time you can see the number of terminals at the bottom also, 1, 2, 3, 4, this is input side, and 1, 2, 3, 4 in the output side. Okay, so you can see here the clearly the how it is connected. So discs, and how the common shaft is connected here. You can see the common shaft, how it is connected. Okay, so aluminum. So you can see this everything. This is a disc and this is the disc. Common shaft is this one. Same operating things. It also braking magnets. Everything is a common. But here what is happened? One current coil is connected one direction, and another current coil is connected to another direction to produce some nullification of difference. Suppose what will happen, without any load, sometimes our meter will rotate to oppose that type of the system. We can say is the creeping effect. The creeping effect, what is the creeping effect? Without any load, the disc will slowly rotates in one direction. So what will happen, due to the rotation of without any load, the disc will rotates, that it will counts the resistor. Now unnecessarily we are going to pay the amount. So that can be nullified using the braking system. This is braking magnets, or we can drill the 2 holes on an aluminum disc in the opposite direction. We can see later that what is the errors. Okay, so these are the common three-phase energy meter. Okay, so let us see the what are the salient points of three-phase energy meters. So it is a 2 or 3 elements. So that means elements means discs consist. Okay, so let us see. Now it consists of 2 or 3 elements. Element means one single phase energy unit, that is the M1, M2 and a disk. Okay, the energy meter for n conductor system requires n minus 1 measuring elements for measurement of energy. Don't bother about this one. That means here what is the meaning? So for example, here suppose this is a energy meter, 3-phase energy meter. I am going to connect the R phase, Y phase, B phase. Here 3 phases, 3 wires connected. Okay, that is equal, here n is equal to 3. N is equal to 3. Then I want the number of elements. Okay, so measuring elements for this is equal to n minus 1, that is equal 2 elements is required. That means here one disk, another disk is required. For example, if I take the R phase, Y phase, B phase and neutral also, that is a 4 wire system. Okay, then n is equal to, now it is what is the case, here n is equal to 4. Then what is the number of elements is required? Here disk is here n minus 1, that is equal to 3. Okay, so how we are going to use it? So I can use here disk 1, disk 2, disk 3 connected in common shaft. So this is the 3 elements. Okay, clear? So that means one element means one single phase meter unit. Okay, so this is clear. Now coming to the 3-phase 3-wire system requires 2 energy meters. Just now we have seen a 3-phase 4-wire system requires 3 element energy meters. Okay, now you can see the classification of 3-phase energy meters based on the number of wires. So it can be classified by 3-phase 2 element energy meter. It is used for 3-phase 3-wire system, and another is a 3-phase 3-wire 3 element energy meter, that is it is used for 3-phase 4-wire system. Just now we have seen. Okay, so once what is happened here, this is for example, this is a energy meter, single phase energy meter. In single phase energy meter, so only we are connected the phase and neutral, phase and neutral and phase and neutral connected. Whereas a 3-phase energy meter, so we are going to connect it RYB neutral, RYB neutral. So we connected this one. Okay, so here so input wires we are connected the whether it is going the RYB 3-phase 3-wire system, or you are going to connect the another 3-phase 4-wire system. So that is the classification. 3-phase 2 element. So here elements are the number of disks, already we have seen. Okay, now coming to the comparison between the single phase and 3-phase, already you know it, just you recall it. So how it is, you can see the comparison. So how this only single disk is present, here 2 disks present, here the only this coil is equal M1, the CC coil, here one pressure coil connected, M2 the PC coil. PC coil connected, it will measure the voltage, and CC coil will measure the current. So power is equal V into I into cos phi. Okay, now energy is equal to, so P into time duration, that is the energy meter. Similarly, it is also consist of M1, here there is a one coil, this is a electromagnet, here is a electromagnet, here also one electromagnet. Okay, the comparison, dear students, just you see it. Okay, operation is same. Suppose, sir, I want to know the circuit diagram. So this is a physical one, how it is connected internally. So as an electrical student, I want to know that, so circuit diagram. Okay, let us say that circuit diagram also. So this is a circuit diagram. So you can see how it is connected. So here 2 elements, 3-phase RYB neutral, here connected RYB, only 3 phases connected, and here is a what is element, this is a one element, this is the another element. So how the connection is taken, here simple, don't worry, dear students. So I will explain this one. Now here we take it. What is happen? Suppose here coming to the, this is the, okay, you can take the another color. Okay, the first case we connected. Okay, now this is a disk. Okay, and now connected here is this one. Okay, now we take the another color. So this is the arrangements. Now this is the aluminum disc. Okay, now so the arrangements already you know, this is common shaft is connected, common shaft is connected. Now coming to our electrical point of view, you require to know that winding. Okay, so what is the winding you are going to connect it? For example, you are taking the, there is the winding here, there is a winding here. Okay, here is a winding connected in series, here also winding is connected in series. Okay, these are the two terminals coming here. For example, you take it, this is the winding connections. Okay, I want to connect this one where I have the load here. This is a load, variable load. I am going to connect it. Okay, R phase, Y phase, B phase, I am going to connect it. Okay, so 3 phases connected, and this is I want to connect R phase, Y phase, B phase, output load. Okay, now here is a phase is the input, R phase, Y phase, B phase. Okay, R, Y, B is the, sorry, B is the, okay, B is the, R, Y, B is the 3 phase supply. These are the input, this is the output. Okay, now how to connect, you can see it. Now I can take another color, R phase, you can take the R phase. Okay, so I can take the R phase, this R phase, for example, I take in the R phase is connected to the, this one coil, and is connected to the R phase. It's over. Now the R phase is also connected to the PC coil. Okay, this up to this one, just listen it. Now R, Y, B, now I connected the B phase. Okay, I can take the color blue color. Okay, I can take the blue. Now B is connected similar to this one, this phase is connected to the another phase is connected here. Okay, here connected, for example, here connected. Okay, so at the same time it is connected here, and this is another terminal. Now Y phase. So how you are going to connect the Y phase? You can see it. So I want to connect Y. So yellow wire, I take it, or you can take the green wire. You can take the green wire. Okay, instead of this one. Now this is connected to the common wire here. Okay, so it is directly connected to the Y phase. Okay, input R by B connected. Now what is happened here? Now whatever this terminal is connected to this one common. Whatever the terminal is connected to this one, it's enough. Circuit is closed. Now whatever the input is connected this one, and similarly R, Y, B, the input is connected this one, and it is connected to the load. 3-phase load is connected. Okay, so this R phase, Y phase are star connected, or something we connected to the, this is 3-phase load. You can see the 3-phase. Okay, now what is happened here? Once the current is flowing here. You can take the another black color, you take this one representation. Now what is happened here from R phase, okay, current is flowing R phase and it is producing it is going to the load, circuit is closed. Then it will produce the flux of phi 1 in R phase. At the same time it is connected to this one, the producing is connected here and circuit is closed. Then it is also produce the flux of phi 2. Okay, now coming to the another phase, B phase here. So the current is flowing here and going here and going connected to the load. Then it will produce the flux of phi 1 and at the same time it is also connected, the circuit is closed here. Then it is also producing the flux of phi 2. So what is happened here, phi 1 and phi 2 is presented, the phi 1 and phi 2 presented in B phase, and what will happen, there is a torque is developed. Due to the torque, so what will phi 1 phi 2 produces a eddy currents E1 and E2 and I1 and I2 in the disc. So due to this one it is also produces I1 and I2 eddy currents. Due to the interaction of phi 1 I2 and phi 1, the torque is deflecting torque is produced. Here also the flux deflecting torque is produced. Due to the deflecting torques, it is approximately the equal load, it produces the same torque. They try to rotate the disc this side, this is also, and both are connected in the same common shaft. Hence it rotate in one direction. Then it is connected to the common our resistor system. This is a basic working principle of three-phase energy meter. Okay, similar to the same previous, same it has a shading rings, it has the same braking magnets, everything is similar to the single phase energy meter. Okay, so dear students, don't confuse it. What is happened? So once again I am going to explain it. So when R phase, Y phase, B phase, that means here once you are connected, R phase, Y phase, B phase, R phase is connected here, Y phase is connected here and B phase is connected here, and we will take the output, for example R phase, Y phase and B phase is connected. What is inside taking place? So you are going to see inside, this is this thing. So these are the all input side, just like this one, and these are the all output side. You can see these are the output sides. This is the output side. What is inside taking place? So there is a inside. Once the flux is produced by the in one element, another element, and deflecting torque is developed, the deflecting torque try to rotate the disc in one direction, and both deflecting torques try to rotate the both discs, and is common connected to the common shaft, and the common shaft also rotates. It is connected to the worm and worm wheel, which are help to register the number of revolutions. Okay, this is the basic idea of three-phase energy meter. Now let us see. So this is the electrical circuit. How it will works, now we have seen. Okay, so if you want the clarity of this figure instead of this one, so let us see a simple circuit diagram. So you can see here, this is the simple circuit diagram. You can easily understand. So here what is happened? R phase, you take the R phase, Y phase. Okay, so yellow color, you can see this is the output, this is the input side. You can see input side. Here R phase is connected across the current coil in series to this one, you can see, and another is connected to the pressure coil, you can see here. Okay, R phase one is connected to the direct pressure coil, and another second terminal is connected to the, you can see what is happened, this is connected to the Y coil, you can see this is the common terminal. Okay, it's connected to the common terminal. Next, at the same time, Y phase is connected common terminal and is connected directly is given, and whereas the B phase, you can see it is the CC coil, the B phase is current coil is connected in series with the load, and another is connected to the pressure coil and connected to the air common band. Okay, so this is the basic simple connection diagram of three-phase energy meter. Now, what are the salient points? It has the two aluminum discs mounted on the same common spindle. Okay, so you can see, and each disc has its own braking magnet. The permanent magnet is provided. A gear train is driven by a common spindle provided in that one, common spindle. A shading rings are provided for each unit separately to adjust the phase angle between the voltage and phi 2. An adjustable magnetic shunt is provided across the one or both shunt magnets, okay, to adjust the phase angle. You can see it. So, what is the each disc has its own braking magnet, and a gear train is driven by the common spindle, and shading rings are provided for each unit, and a adjustable magnetic shunt is provided across the one or both shunt magnets. Okay. So, at the same time, two separate pressure coils. So, here is the M2 of R phase, M2 of B phase connected in parallel, and two separate current coils are provided here, R phase and Y phase connected in series with the load. Okay. So, these are the physical connection diagrams in three-phase induction motor. Now, let us see the working principle of three-phase energy meter. What is the working principle? The working of each element is similar to that of single phase energy meter, which we have already studied just now. So, here one important note you have to remember, that the driving torques of the two elements should be exactly equal for each amount of power. Okay. So, you remember that thing. What is the note here? The driving torques, the TD of two elements should be exactly equal for equal amount of power, because automatically power is the same balanced load. Now, check for equal driving torque of the two elements, whether the two TDs developed are equal, or because that is dependent on the load of each on each phase. Okay. The coils are energized from single phase supply each element. Before going to use it, you have to check it first on a RS meter. The coils are energized from single phase supply, that M1, M2 is energized, and a pressure coil are connected in parallel, and current coils are connected in series with a load. One of the current coil is reversed to oppose the other, so to nullify the any difference between the torque differences, deflecting torques. Okay. So, and the disc should not rotate as two torques are equal and opposite, otherwise what will happen? The disc will try to rotate. So, that is why we have to adjust it. If there is a slight motion of the disc, difference of the torques occur, so we are going to adjust the thing to nullify this thing. Okay. A magnetic shunt is adjusted to a position till there is no rotation of the disc without any load. So, that means two torques are equal and opposite produced by each element. The phase displacement and friction compensation and position of braking magnets for each element are adjusted. The braking torque is provided by adjusting our permanent magnets, so which can overcome the friction and as well as the phase displacement. Okay. So, you can see how the three-phase energy meter connected in our circuit, because you are the electrical students, you can easily understand. You can see this one. What is consist here? Three-phase energy meter connected. How many wires is present? So, R phase, Y phase, B phase and neutral. Here 3 phase 4 wire system. How many elements is there? Here 3 elements is required. So how it is connected, you can see here. This is the load and this is the input side, this is the output side. Okay, R phase is connected here and R phase is taken here, and Y phase connected here and Y phase taken here. B phase connected here, B phase taken, and neutral is connected here, neutral is connected. So similarly, you can see the practical wiring diagram of 3-phase energy meter. It consists of how many terminals? It has 8 terminals for 3 element systems, whereas only 6 terminals in case of the 2 element systems. Okay? Here there is no neutral business in case of 2 element system. Here 3 element system we require the 8 terminals. In 2 wire, so 2 element system we require the only 6 terminals. Okay? That is a simple difference. Now let us see this is also same thing, how it is connected internally. So if you want to go inside how it is connected, how the 3 elements are connected. So that means here the perfectly each element act as a single phase energy meter. No common business with the another phase. Here we are connected the R phase and neutral, Y phase and neutral, B phase and neutral. So this is a one element single phase energy meter, single phase energy meter, single phase energy meter. It has a one disc, it has another disc, it is another disc. It's common shaft only. Okay, so clear. Now let us see this one. So this is a 3-phase 3 element energy meter. Okay, generally used for 3-phase 4 wire systems. The connection diagram you can see simple. Okay, so this is the connection diagram. This is the one elements. So you can see this is a one disc, here is the one disc, here is another disc, here is the another disc. Each R phase, you can see R phase how it is connected. R phase is connected to here and is a CC coil connected here, and it is going to the coming here R phase, whereas the PC coil is connected to the one R phase, another is connected to the common neutral. You can see here common neutral, and at the same time Y phase also Y phase connected CC coil, another is connected to the load, and PC coil connected Y phase, and another terminal is connected to the common terminal. We can see here common terminals. Okay, simple R phase connected, R and neutral is connected. One is the CC coil connected in series to the load. Okay, so that is connected here, and this is connected here. Here is connected to the load, and PC coil is connected to PC coil and is connected to neutral. Okay, and this is a PC coil. This is a CC coil. Okay, it will measure the current, it will measure the voltage, correspondingly it produces the deflecting torque. Okay, so what are the salient points of this one? So it has the 3 single phase elements working on 3 discs. 3 discs are fixed to the same spindle, common spindle. The spindle is provided on a jeweled bearings, frictionless bearings to easily to rotate. Okay, now the discs revolve in the air gap between the 2 electromagnets M1 and M2. The flux due to the 2 electromagnets produce the rotating field. 3 braking magnets are provided in each disc to produce the controlling torque. The torque and speed of a disc is proportional to the power consumed by that phase. If time is considered, the number of revolutions are proportional to the energy. The adjustment of power factor and friction is done by shading rings provided on the M2 center limb. The spindle is geared a chain of wheels which can use to record the number of units or number of revolutions. The resisted mechanism is indicated the energy supplied through the meter. Okay. Now these are the 3-phase energy meter, two element system, 3 element systems. What are the different parts consist inside, how it will works, and how we are going to control this rotation of disc, all we have seen. Dear students, it is a very simple. If you understand single phase energy meter, and now 3-phase energy meter is very easy to understand. I think it is clear. So all are basics, only circuits. Now let us summarize what we have seen in this session. A 3-phase 3-wire system requires 2-element energy meter. The driving torque of 2 elements should be exactly equal. The torques are equal for equal amount of power passing through each element. This condition is checked by the energizing the coils from single phase supply. At the same time, we have seen that the pressure coils are connected in parallel to measure the voltage, and the current coils are connected in series with one reversed to nullify the deflecting torque. Any difference with deflecting torque. If there is a slight motion, shunt magnet is adjusted till speed is 0. That means without any load on a meter, it should not rotate. Okay, so that is the creeping effect is nullified. And 3-phase 4-wire system requires 3 elements. A 3-phase 3-wire system requires 2 elements. Okay, so these are the basic things of 3-phase energy meters. So thank you for listening my class.